And we're finishing this last segment of the day about GraphQL and GraphQL technologies with one of the biggest advocate and community advocate of GraphQL over the last few years, which is Jesse Martin. Hi, Jesse. How are you?
Hey, Mehdi, how's it going?
Yeah, I said one of the biggest advocates, right? But you've done your part, right? So it's important to notice it, with conferences and with events and with content. So yeah, we're really glad to have you for GraphQL's second act, A Practitioner's Tale. Thank you very much.
All right. So should I just go ahead and get started then? I guess that's my cue to get started. Well, thanks, Mehdi, for the welcome. I don't know if I'm one of the biggest advocates in the space, but I have been around a little bit in terms of one of the longest in terms of advocating for GraphQL specifically. So who am I? Currently a sales engineer at Hasura, specifically targeting the EMEA region. I've been a GraphQL educator for over the last 5 years, really specifically on the technology itself. So what we're going to see in today's talk is actually, when I say a practitioner's tale, it's really my observations of talking with customers and seeing sort of where the puck is going. Aligns a little bit with the company that I'm currently at, but mostly it's actually what I see happening. So that gives you a little bit of context. I have a background in more of the branding strategy, consultants kind of side, so that sort of taints a little bit of what I'm going to say, or flavors it depending on how you want to call it. But yeah, that kind of gives you sort of the context. I'm also a dad. I got 4 kids, so if I ramble a little bit, apologies. If I drop a dad joke, no apologies, but there we go. To understand a little bit about my current context of when I'm talking about GraphQL, we need to understand a little bit about my current employer. So Hasura is an open source engine that is allowing you to convert GraphQL into underlying data sources. We're trying to see where GraphQL can be used as sort of a normalized data layer, if you will, where you could say across SQL, across REST requests, across all different kinds of data sources, maybe I can just use GraphQL as sort of a normalized language to be able to access different kinds of data, something that we're going to get into a little bit later on. And so what it has a lot of the different kind of functionalities you would need, but I'm not supposed to give a vendor talk. So I'm going to kind of just jump over this really quickly. Essentially, think of it as a tool that normalizes data access across different tools, sitting somewhere here in your stack where you've got essentially your different data sources connected to it. And it allows you to work with your databases, your clients, your microservices, and whatever else. Yes, I said microservices because we're going to have a look at that point a little bit more specifically. This talk is a little bit of a response to some negative motion in the community that I really want to clarify about. Yes, GraphQL can do a lot more than a lot of people think. So stay tuned. And yeah, so if you're kind of curious about what I mean about it being sort of a converter, kind of works like this. Incoming GraphQL query converts it automatically for you into what the underlying data source needs, in this case being SQL. So gone are the days of writing resolvers by hand. We do this stuff for you automatically. I have talks on that topic if it's something that's more interesting for you, but yeah, fun stuff. A lot of companies use us. Fortune 500 companies, big players, lots of people. Has an open source core, which is great. So if you're wanting to have a play with it, go ahead and have a look. But it's definitely something that's getting a lot of validation in the community. So anyways, that's who I am. That's what the company is. But today's talk requires you to have requires two assumptions to be made. One is that you all know a little bit about what GraphQL is. I'm hoping that's true at this point in the history of GraphQL, as well as you are aware that people on the internet get angry about silly things, because this talk is a little bit of a response to some of those silly things. Namely, those things are going to be that the second point on this slide, and that is that GraphQL is not just for front ends anymore. And that's mostly because GraphQL is sort of becoming a data SDK, if you will. Once you've connected all the pieces to your GraphQL API, you now have this normalized SDK across all your different data sources, and that's a really powerful way to build. something that we're going to go ahead and have a look at why that is so powerful, and hopefully gives you the desire to try it out, that pattern for yourself. Okay, so again, this is a practitioner's talk. So strong opinions, loosely held, but strongly inferred from my experience, or the short version of that is haters going to hate. So let's go ahead and have a jump into this. I'm going to start with 2 bold statements as generalizations. I'll try to explain those a bit more in specific. I'm going to rush through these slides because I have a 30-minute talk in 20 minutes for you. But basically, statement number 1 is if we're going to look at REST versus GraphQL, REST is preferred by single service providers, and GraphQL is preferred by multiple service consumers. And we're going to have a look at where this actually comes from. And it is derived from the fact that if you look at modern data access challenges, then you're going to see that there is a plethora of different ways to connect to your data. You've got SDKs, APIs, ORM-driven development, all kinds of ways that people are having to learn to access this data. And so if I'm trying to connect to a REST service and my database and use some sort of evergreen technology through an ORM platform, my developers have to learn a whole bunch of technologies to be able to access, provision, and work with this data in a really annoying way. And the ideal use case that I would like to have is like, what if I could just sort of have all of these different data sources connected through a single access point? Like, what if I just had to learn one entry point to be able to get to my REST APIs, to be able to get to my microservices, to be able to get to my databases? It would be really nice when I'm trying to build out today's modern complex applications if I could just simply have one entry point. And that's kind of the picture of where GraphQL rises, because when we're talking about REST, it's really easy to model this around deliverables, because I can say this is the endpoint and this is the payload. Like, I get a specification, I'm able to say this is what's supposed to be delivered at that endpoint, and done. Like, you hit that path and this is the data that gets sent, and here's some documentation that explains that to you. But when it comes to the GraphQL space, I have lots of different data that's changing in terms of when I'm consuming things. And it's much easier to model around the different dependencies of data that I actually need. So if I'm going to be building out a product, maybe I want to actually say, these are all the different pieces of data that will be at some point needed in this process. And I would like to be able to design a single API that allows me to essentially make that request. And we see REST trying to emulate those kind of behaviors as well, using things like sparse fields or whatever else. This is a functionality that consumables are wanting to have, sort of that shopping cart analogy of getting data as you go down the aisle of product delivery. Now, I am using the word model here very specifically because if anybody has actually tried building out a GraphQL API and building out sort of this general data layer, this is a lot easier said than done, going from the whiteboard to the actual implementation. There's 2 totally different things in GraphQL land, and those are some of the problem spaces that companies like Hasura and others actually are trying to solve, is to make it less painful. So the value here of when we're talking about connecting all the data pieces as designing out a consumable-based pattern is sort of what I like to refer to as Metcalfe's law for GraphQL. And if you're not familiar with Metcalfe's law, that basically means that the more nodes you have in a network, the more value the overall network has. So if you're talking about GraphQL land, well, actually, let's have an example. Look at this here. Let's go ahead and just imagine we had these 3 totally random nodes inside of our network, right? We have users, coffees, and scooters, which essentially have zero relation to each other, or maybe some, they're sharing a user edge. But if we start to build out this model, we start to enhance it with some more nodes, and we start to draw some of the connections between these nodes, suddenly we actually can see that if I were to write a query or somehow be able to use all of these edges together, I might actually get like a recommendation engine, right? Like I could say, hey, if you're charging your scooter by my coffee shop, you get $1 off from whatever thing this is, or you've bought 5 coffees in the past, charge your scooter here, whatever it might be. I could come up with some kind of crazy business model that makes sense by connecting more and more nodes into a graph. Again, talking about data consumables. And that's not just theoretical, right? Because if you're talking about all the different pieces of endpoints, weather APIs and everything else that would be needed to actually execute on this, this is what the Hasura interface looks like here. But let's zoom in here on the query. Like, this is really much more attainable for my developers. They're able to see the pieces of data that they actually need to access through these edges and relationships of this graph. Now that changes entirely if I'm doing payments or if I'm doing other kinds of functionalities. This is something that becomes really, really powerful for my developers to work with. I've normalized all these different data access points in a way that my developers are able to build quickly and effectively. So super powerful. And some of the key benefits of this is that there's generally less overhead for orchestrating the services. I've got a single entry point, all my nodes are connected, and I've been able to provision, secrets and manage all of the different governance layers at one location. And now my developers don't have to worry about any of that. They can just work with the information they have in scope. Oops. I have a smaller control plane overall, which is actually great for security because I'm not having to expose a lot of services and like having to expose my secrets and credentials in each microservice as I go. I have a reusable pattern. I can implement this again and again and again, no matter what it is I'm building with. And frankly, it's totally agnostic to consumers. And that last piece is the one where people seem to have an issue with, is they want to say, no, the consumer has to be a front-end application, or it has to be a mobile application. Some people even go so far as to say. And I'm saying, no, this idea of data dependencies is really interesting. And let's have a look into this data dependency term and see why this potentially does not need to live just on a client level. So some example diagrams here. Let's talk about a typical federated GraphQL service pattern, standard e-commerce kind of thing, right? So you've got queries in blue, mutations in red, and you've got users, orders, and products representing SQL or REST APIs, whatever else you want on the one side. And then you've got a bunch of microservices or other REST APIs for backing up your mutations for things like logging in, logging out, purchasing, or edits. But if you look at this, there's a dependency that purchase has that actually needs to be accounted for. Because if we go ahead and actually look at purchase specifically, well, purchase actually needs to read from user, order, and product. And so what if I could just use that same API to be able to say from inside of purchase, I'm going to step out, grab user, order, and product, and pump it back in? Like, why not? But in the modern system, we're not allowed to do that. Like, we have to say, no, actually, you have to jump back out to REST land. You have to jump back out to the traditional data access patterns from inside of a purchase microservice. You need to go back to the getting the user, then getting the orders, and getting the products. You're not allowed to actually leverage the same API shape. Like, wouldn't this be just a lot cleaner and a lot easier for my developers to be able to work with? I argue it would be, and a lot better, because this is just a way that we're actually used to designing. I mean, going back to something a bit more or less abstract here, let's say you've got a realistic product here shaping a financial product, right? You've got a whole bunch of different network credit average and pending purchases. You have a whole bunch of data dependencies that you're trying to do for a risk assessment on a specific product you're building. And these are all representing like realistic, like, you've got REST, you've got SDKs, you've got more microservices, and you've got maybe raw SQL reads. Why would you force your developers to have to go back to individual REST implementations and SQL calls and everything else from inside of each of these microservices if you already had them connected and the value of the graph was already in context. Like I could just reutilize the same work from inside of these microservices. And to be totally honest with you, this is actually a very real pattern that we have seen that spans every vertical you could imagine. Multi-tenant applications, real-time telematics, DORA metrics, healthcare, finance. This is something that a lot of developers are starting to see that, hey, once that connect to the world, I should be able to just kind of access this data. Now, I'm getting a little bit on time here, so I'm going to kind of rush along, but some of the dissenting opinions, again, everyone's allowed to be wrong, to using this approach where we talk about just utilizing one graph for all of your data access patterns, is, starting off with, it's not what GraphQL was created for, right? The pattern and the history of GraphQL was designed for mobile applications trying to optimize data payloads so you're not overfetching data when you need it. Right, that's not what it was created for, but it wasn't exactly what it was designed for. So you're actually able to utilize this pattern for accessing your data in a much more efficient and effective way, because the idea was about getting custom payloads in context where you needed it. That's a design problem. What about latency? So there's a question about whether or not this introduces new latency as you're creating some more round trips. And again, if you're talking about any kind of enterprise grade API platform, the reality is this is only marginally slower than the most optimally tuned REST alternative available, right? If you're talking about really like fine-tuned, high-speed data access patterns, yes, there will be some latency here. But I've seen a lot of the architectures that people are building, and frankly, we're talking about gateways within gateways, and this is not actually any slower than that. So what are the gotchas about this pattern, about using microservices, using GraphQL within microservices as well as clients? There's no gotchas. So I'm just kidding. Latency is actually a real one. So this is something that we're trying to solve with Hasura. Everybody's trying to make this be better. A lot of caching utilities and things coming out in that regard. GraphQL on the edge is a really fascinating space. So yeah, latency is a real thing, but it's something that is a solvable problem. And then new APIs will have new problems, right? So things that we solved in REST land a long time ago, we're having to reinvent the wheel in GraphQL land. But again, these are all things that are solvable problems that actually companies like Hasura are dedicated to solving. Specifically, speaking about what Hasura is doing to try to move towards this space, we're talking about API design very quickly. We're shifting ourselves to thinking very much more about model-driven in terms of API design, where actually the backing data services become secondary to your overall shape. That allows you to be 100% declarative, where the model is going to be defining your actual data affordances, like what you can do with the data. And so you'll be able to have a really declarative structure to what you're designing your data shapes with. And the model defines its relations and shapes to other pieces inside of the network. So you're able to say, let's talk about these nodes at a really fundamental level, and then whatever happens to be the best fitting storage pattern behind that, well, you'll be able to tell us where you're storing your users or your scooters. And to be totally honest with you, this approach with model-driven is going to essentially become GraphQL agnostic. If there's another graphy-like API structure that allows this interconnection of nodes in a more performant way, we can shift to that, because what we're talking about is model-driven, because the tooling is what's going to be converting a model to an API, where the model and the API are actually completely independent upon what you're trying to do. So it's kind of what we've been doing actually all along, a little bit, but I know I'm a little bit out of time, and frankly, this is a talk they said that I wasn't allowed to give, so I'm going to stop it from there. But I did give this talk for API Days in New York, so if you don't go back and watch the YouTube videos from the API Days community, there's so much great content out there that they put up on YouTube, like years of data probably at this point, to go back and watch what's out there. So if this whole topic about model-driven APIs is interesting, check out API Days New York. I did give a talk on that. So where can you find out more about this general topic on using GraphQL and microservices, model-driven design, and shaping everything. Obviously, you can find it from any of the Hasura properties, as well as just reaching out to me directly on Twitter. I'm always happy to answer questions in DM. And that is it for my talk. I'm a little bit over, but hopefully not too far. And yeah.
So let's go for some queries, right?
Query.
Now, I have a question for you. Like a lot of people say it won't scale. A lot of people say it won't be secure. A lot of people say it will be not possible to really version. It will not be possible to monitor GraphQL queries. Let's say a lot of things have been said. API GraphQL is killing API design, right? So many things that has been shared by people, thinkers thinking the long term of GraphQL. So after 2015, the official, after 8 years, right? I think it's 8 years. It seems it overtook all of this. No?
Yeah, every time there's been a new complaint, and they're fair ones, totally like fair things. Again, we talked about what things we solved in RESTland a long time ago came from real needs. GraphQL has had a way to answer each of those. Sometimes it's a little bit of a different way. Like when it comes to API governance, well, everybody's saying, well, we need to look at the individual fields. It's like, well, to some extent, but maybe there's something different here where we're looking at the request of data, the client requesting that data, and actually your database utilization underneath. Like in the Hasura pattern where we're converting GraphQL to SQL, the fields are less interesting because you can remap those and rename those, but what the actual data utilization underneath mapped to that request becomes more interesting for me as a cloud ops guy, because I can say, well, this query is actually doing a sequential scans across my entire database, and that's bad, and I can figure out how to optimize that, and I'm not having to spend a whole bunch of time fine-tuning fiddly little bits of glue code. I'm just able to say, no, query this in a different way, or add an index here, or whatever else, and then the in-between part solves itself.
Yeah, no, it seems, technology and imagination came to answer to all the questions, right, over the time. Also a question about GraphQL adoption. It most of the time GraphQL is loved by developers and not so much loved by architects who prefer RESTland, as you call it. Do you still see that shift, or let's say the alignment between developers and architects about GraphQL ability to stay and scale over time? Is this a split still?
I would say there's actually a split with architects. There's a split with architects, right? So you've got architects who design APIs are frustrated by GraphQL sometimes because it changes what they're having to do. Architects of product, people who are trying to build out the payment platform, people who are trying to build out the data networking layer or whatever for a massive company, love GraphQL because it's allowing them to think about models inside of a system, which is what people loved all along. They loved the design driven, they loved the object oriented. The problem was the tooling just really was terrible, and it was never a scalable solution. So if you're able to say, give me models, I'll give you an API. Frankly, for an architect, that's fantastic because that allows us to really focus on the things that we really enjoy doing and not worry as much about the details, making sure they're covered, of course, but that allows us to be able to focus on the true design of our architecture, and then making sure that the other pieces are covered, like security, governance, and so on.
Last question about the production aspect. It seems on production it can save a lot of resources, by solving the overfetching, of REST and many other things. But the scalability on large organization, where people used to say GraphQL works only if you know the users. So if you really control the client and the server, to be sure that people know what they do, versus one API in the wild that people can discover and use, not knowing why it has been designed for. Is it still valid or not?
That's valid to an extent, because I differ a little bit from my employer in this regard, that I'm not a huge advocate of saying that GraphQL is awesome for public APIs. Public internal APIs, sure, where you're saying, okay, inside of this massive corp, you're able to go ahead and say, this is the data available for building with, and building on a catalog on top of that. I think that all makes sense. But if you're saying I'm Stripe and I'm just exposing a GraphQL API for everybody to consume, that's getting really challenging. There's solutions for that for sure, but that's an area where it would be a good question to say whether or not REST is potentially a better solution there or not. And I think that's, again, if we're talking about models to any API, that's solved by that pattern, because you could say, well, in this case, this should just be a REST API, not a GraphQL API. Maybe. But I do think that for publicly exposed APIs that are available for anybody to go out and build with, if I'm making a weather API service, for example, there's a valid question there whether or not that's a good idea, that you'd have to really think about some additional tooling that you would need.
Perfect, Jesse. Thank you very much for answering all these questions, all these queries, actually, as you asked. Yeah, and see you at another API Days conference.
For sure. Bye.
Thank you very much for being with us.